A very good day to sir. So now I would like to start my presentation for the project part A. So our group member include me, Tan Qiaozhen, Pan Zilong, and Lo Fiki. For the question 1, our question is required to design a DC voltage feedback bias. From the question given, we note that the saturation current is 9 mA, the collector to emitter voltage is 17.5 volt, and the base current IB is a 20 mA. According to these 3 points, we can create the base fit line to find the VCC, which is a 26 volt. Before we start our analysis, we draw the configuration of the DC and voltage feedback bias. For the DC and voltage feedback bias, the base resistor RB is connected to VC instead of VCC. Based on the graph plotted and characteristics stated, we know that the VCC equal to 26 volt, VCE equal to 17.5 volt, saturation current equal to 9 mA, base current equal to 20 mA, and the base voltage equal to 6 volt. So now we are finding the VE, which we use the formula VBE equal to VB minus VE, and we get the final answer is 5.3 volt. And then we find the VC, which use the formula VCE equal to VC minus VE, and the final answer for the VC is 22.8 volt. So then we will find the RB used with the formula VCB divide with IB. So the final answer comes to 840 k ohm. Then we will find the value of IE. Before that, we assume the RE equals to 1 k ohm, so we use the IE equal to VE divided by RE. So the final answer is 5.3 mA. And then we find the RC, use the VCC minus BC divided by I prime C. So the final answer is 604 ohm. And then we find the IC with the formula I prime C equal to the IC plus IB. So the final answer is 5.28 mA. And last, we find the value of beta, which the value of beta with the formula beta equals to IC divided by IB, and the final answer beta equal to 264. Now we need to consider the standard value from the table, standard value of commercially available resistor. From the RB, we get the theoretical value, which is the 840 k ohm. So we take the nearest standard value, which is the 820 k ohm. Then for the IB, we use the 20.5 mA. It is within 5% of specific value, so it is accepted. So for the RC, the theoretical value we get is 604 ohm, and the standard resistor value is 620 ohm. So the IB, we using the standard value, which is the 5.16 mA, and within 5% the specified value is acceptable. And this is the final circuit for the design DC and voltage feedback bias. So that's all for my presentation. I will pass to my next presenter.
So I will explain how our group is solving for question 2. For question 2, the instruction is given that we are required to design a clamper to perform the functions indicated in the figure shown. As well, when we inspect the figure, actually the figure is showing the output, then we could find out this is a positive clamper circuit, since the waveform was moving vertically outward at the output, while the amount of the shifting will depend on the value of the DC reference voltage. This is how the schematic diagram of a positive clamper circuit. It consists of a forward biasing diode, a capacitor, and a resistor. The value that we use for resistor is 10 kΩ and the capacitor is 6 microfarad. Then we could calculate the charging and discharging time constant, which is the tau. Next, we could find the time needed for the charging and discharging of capacitor, in which the charging time is 0 since it is 0 tau, and discharging time is found by using its final condition with 5 tau. Why we use 5 tau? This is because, as a graph below shown, 5 tau is a steady-state fully discharged period of the capacitor. Since the discharging time is 300 seconds, which is greater than the charging time 0 seconds, then our resistor and capacitor value is acceptable. Next, we will find the value of VDC. Then we need to ensure the voltage in the circuit, whether it is tally with a figure from the questions. In this case, both of the reverse and forward bias is implied, in which when reverse bias, the diode will act as an open circuit, while when there is forward bias, the diode will become short circuit. In this process, we use the technique learned, for example, mesh analysis, Kirchhoff voltage law, KVL, and analyze the diode by drawing the simplified circuit. Lastly, we could conclude that the circuit is acceptable since the amount of the shifting, which is the value of DC reference voltage, is 1.3 watt, and this condition meets our question needs. Therefore, our designation of clamper is as a figure shown. With a 10 kΩ resistor and 6 microfarad of capacitor, diode is 0.7 watt since it is a silicon diode, while V1 is as a VDC is 8 watt. That's all from us. Thank you.